So basically today we will study physics AS chapter number 2, kinematics. The core concept of kinematics is basically a different distance and displacement which will give. So we have distance and displacement, so we will like get distance, different types of velocities, different types of motion, different types of motion, and we will get equation of motions from here, and all this will also give us time graphs. So this is the time graphs. Distance S and D graphs. So displacement and distance. This is basically distance is basically the distance is the total movement in meter you have to do from point A to point B, something like this. So if you travel like this, you have to travel it like here. Otherwise we have to get this. Okay, I will also draw. So basically displacement would be basically taking a shortcut like here. This is the distance displacement displacement is distance from point A to point B. Next we have types of graphs. We have basically distance time graphs, we have distance speed time graphs. No, there's also distance time graph. This is increasing speed, constant velocity, zero acceleration. Acceleration is not included because we are not measuring a direction. So from here 0 would be 0 here would be, oh sorry, let's just withdraw it. So yeah, increasing speed, constant velocity. So at 0, the 0 no sorry, I'm just kind of tired. This topic I basically am revising very late. I myself am a student, so I really can't bother correcting this. So yeah, increasing speed, constant velocity. So basically increasing speed, constant velocity. So at 0 There is no movement or anything. Force zero at zero is nothing. Y-intercept. So area under the graph, this would be displacement. If it's like this is decreasing. Oh, sorry, I'm getting used to this. Decreasing speed, negative velocity, negative velocity, decreasing speed. I also did not discuss, velocity. I just, sorry if I am not actually presenting this in the right way. We also have this, which would be constant, constant speed, zero velocity. Basically, speed is the by object in unit time. So basically, speed is basically distance covered without no direction. You can be going up, down, north, south, east, west, southwest. It doesn't matter. It's basically just moving. It's meter ms minus one. Base unit velocity. Velocity is displacement over time. This is the better. You can also, you can't, like, from what I've seen, you cannot write like uh, you cannot write, this distance velocity is speed per unit time. What I've seen in past papers, it's not per unit time, it's over, it's displacement over time or displacement per unit time, which is ms minus 2. Speed is s equal dot, v is u minus v or t. Initial velocity minus final velocity, or this is final velocity minus, sorry, initial velocity. I'm a bit jumpy. Final velocity minus initial velocity over time. The area. So let's talk about displacement time graphs. Sorry, I'm just brain farting. I might not even upload this recording, but I'm very lazy, so maybe I will. So displacement time graphs are a bit different. They are basically, like this, this, this. Basically, this is area under this curve is meaningless. It cannot be calculated. Well, maybe you could calculate with calculus if that's the master area, but that is not for AS syllabus. Area under curve is meaningless. Time increasing velocity, constant acceleration, sorry my pen is basically down doing something weird. Increasing velocity, increasing velocity, constant, this is constant velocity, constant velocity, constant velocity, this is the decreasing velocity, decreasing velocity, decreasing velocity, constant, zero acceleration, zero acceleration. So next we have velocity time graph. I might be wrong about this, so you can check it down later. Something like this, or let's do abstract. So this is velocity time graph. Area under curve is displacement, increasing acceleration, constant velocity, increasing velocity, I'm on increasing velocity, constant acceleration, increasing velocity, constant acceleration, constant velocity, zero acceleration, constant v 0 a, decreasing velocity, negative acceleration, negative. So yeah, this is covered. So next we will now, since we are done with the graphs, we will now do basically so now we are done with this. So we now like to talk about equation of motion equations. Motion. First we have S is equal 80 I forgot about this, but because I didn't actually remember them, so I will put this out, edit this and put it later here. So next we have projectile motion, projectile motion, projectile motion. So basically, if some object is moving in a project like a half circle, semicircle way, so basically it travels from here. So this will be vectors, two vectors, cos x, I think like word wait open to hypotenuse. So yeah, this is sin, this is cos. So if it's moving, we will do this, and if it's here, so if we have to calculate, the upward, so we use if we have to travel from here, we will show this sin, but if we have to here, we will apply equation motion, and so on. So for this time I'm done, but I will definitely